Hello, everyone. All right, so this is the beginning of Unit 4, so this is the first lesson. So this is going to be just about writing linear equations. So a lot of 4a we've actually already done before, so most of this should be a review except for maybe the last part. All right, so we are going to be writing equations in slope-intercept form. So as you know, we're looking at the equation y equals mx plus b, where m represents your slope and b represents your y-intercept. So another way to say slope, just in case, is rate of change. So some of your equations or problems may use the word rate of change instead of just explicitly saying the slope. All right, so given whatever information we have down here, we want to be able to write the equation in slope-intercept form. So looking at the first one, we're given the slope and we're given the y-intercept. So just exactly how slope-intercept form is written, y equals mx plus b. We're just going to replace the m value and the b value. So our m value is 2, which is our slope, so y equals 2x. Then our b value, which is 4, so plus 4. So that's our equation for the first one. So looking at our second one, now we have a slope of -3, and we have a coordinate of 0, 8. So if you notice, your y-intercept, if it's written as a coordinate, it's always going to be written as 0, a number. So whatever that number is right there, that's going to be our b value, our y-intercept. So in this case, it's really similar to the very first one. I still give you the b value. I just have it written differently. So in this case, we're going to have y equals -3x and plus 8. So y equals -3x plus 8. All right, so now looking at our third problem here, it's written a little bit differently. Now I just give you 2 coordinates. So we've actually had to do this before. So first thing we have to do is find our slope. So I'm going to label first, so that way I can do my slope formula. So y2 minus y1 is x2 minus x1. So based on how I have it labeled, remember it's change in y over change in x. So I'm going to do 6 minus 10 over 2 minus a -2. So be careful here. Anytime you subtract a negative, that turns into plus a positive. So in the top, I'm going to have 6 minus 10, which gives me -4. And in the denominator, I have 2 minus -2, which is going to turn into 2 plus 2, which is going to equal +4. So when you simplify, you get a slope of -1. So now I need to find the b value. So what I'm going to do is I'm going to start in slope-intercept form. So I'm going to take my slope, and I'm going to write that for my m value. And then I want to take one of my coordinates. So I'm going to take one of my x, y values for x and y, and I'm just going to plug it all in. So I'm going to use the coordinate that has the smaller number values and also the fewer negatives, just to make the math a little bit easier. So for my y value, I'm going to plug in 6. It's the y value of my coordinate. For my m value, that's my slope. I'm going to plug in -1. And for my x value, I have a +2 from my coordinate. So now I just have my b value that I need to solve for. So I'm going to have 6 equals -2 plus b. Now in order to solve for b, I need to get rid of that -2. So I'm going to add it on both sides. So I'm going to have b equals 8. So now I'm going to take both my slope and my b value, and I'm going to write them together. So I'm going to have y equals -1x plus 8. Now, whenever you're writing your equation and your slope is, say, 1, for example, you don't actually have to write the 1. So your equation here is just y equals -x plus 8. So either one of these equations would be accepted. Just know on an assessment, this, oh, where'd my 8 go? There we go. This is the value that you're going to see. All right, so a similar situation over here for number 4. So label, define the slope. Hello, there we are. All right, so my slope, which is y2 minus y1, so I'm gonna have 2 minus 1 over 4 minus 2. So that's gonna equal 1 over 2. All right, so now I'm gonna do the same thing as before. And you get to choose a coordinate. So I'm gonna choose 2, 1. Numbers are smaller. All right, so start with y equals mx plus b. So plug in 1 for y, my slope, which is 1/2, my x value, which is 2, and now I want to solve for b. So 1/2 times 2, which simplifies to 1, so I have 1 equals 1 plus b. Now I'm going to subtract 1 on both sides, so I just have b equals 0. So what this equation is going to look like when I take my slope and my b value, y equals 1/2 x plus 0. But I don't have to write that 0. So my equation is just y equals 1/2 x. All right. So now looking at number 5. So as mentioned before, rate of change is just another way of saying slope. So this is your m value. And then just like mentioned before, if I write 0, a number, this is your b value. So your equation here is going to be y equals 2/3 x plus a -5. So whenever we're adding a negative, that just turns into subtraction. So this is just going to be y equals 2/3 x minus 5. All right, now looking at number 6. So this one's not nearly as intuitive just because of your rate of change. So your rate of change here is 0. So what that means is this is actually going to be a Hoybuck's problem. So if you remember, if we have a slope of 0, that actually refers to Hoy, not Bucks, which means we're going to have a y equals equation. So I'm going to have a y equals equation. So I'm going to look at my coordinate over here, and I want to know the y value of that coordinate. So because my y value is -1, my equation simply is y equals -1. All right, so that's kind of the shortcut way to do it, but I'm going to kind of do this the old-fashioned way just so you can kind of get the same idea. So if I start with slope-intercept form, I'm going to plug in the slope, and I'm going to plug in the coordinate. So for my y value, I have -1. For my slope, I have 0. For my x value, I have 3. And I want to solve for b. So anything times 0 just gives you 0. So you're going to have -1 equals 0 plus b, which just means that b is equal to -1. So now in slope-intercept form, now I want to plug in my slope and my b value. So if I have a slope of 0 and then a b value of -1, anything times 0, as mentioned before, is just 0. So it's just y equals -1. So you get the same thing either way. So even if you don't recognize the pattern with Hoybucks, you can still do it the traditional way. Okay, now over here for number 7, now it's written in function notation. So if you remember, just kind of off to the side here, f of x is the exact same as y. I can actually take both of those values and rewrite them as a coordinate. So it would be x, y. So I'm going to do the exact same thing with the function notation written here. So I have f of 0 equals 5, which means 0 here is going to be my x value, and 5 here is going to be my y value. So I have 0, 5. Then over here, for f of 2 equals 7, and I have 2, 7. So those are my 2 points. So just like above up here, I'm going to do the exact same thing. Between the 2 points, find the slope, plug it in, find the slope-intercept form. So to find the slope, x1, y1, and x2, y2. So I'm going to have, all right, so 7 minus 5 over 2 minus 0. So that gives you 2 over 2, which simplifies to 1. So we have a slope of 1. All right, so now it's going to go to slope-intercept form. So y equals mx plus b. So it doesn't matter which coordinate you actually plug in. However, if you notice, if you look at your coordinate here, we have 0, a number, which means this 5 right here is your b value. So we can just go directly to the actual equation. We don't have to solve for b. So I'm going to plug in the b value and the slope. So I'm going to have y equals 1x plus 5. And as mentioned before, we don't have to write that 1. So our equation here is just y equals x plus 5. All right, so I would definitely say pause here and actually try this one on your own. Or if not, that's totally fine too. All right, so this is going to be -2, 4. And the coordinate over here is going to be -2, -5. Now, one thing I want you to notice, before you even start anything, look at the x values. They're the exact same. So if the x values are the exact same, that's an indicator that we're going to be looking at bucks. So what that means is we're going to have an x equals equation. So if we're taking our x value, it's just going to be x equals -2. That is our equation. All right, so kind of like before, if you don't recognize the pattern, there's still another way to do it mathematically. Nope, we need that, just kidding. All right, so let's say we start by finding the slope. Nope, there we go. Okay, so the slope, so y2 minus y1, so -5 minus 4 over -2 minus -2. So that's going to give you -9 over -2 minus a -2, which turns into -2 plus +2, which is going to give you 0. So you can't actually divide by 0. So what that means is this is undefined. So whenever you have an undefined slope, that tells you it's going to be a Hoy-Bucks problem. But because we have an undefined slope, that's our indicator that we're going to be using bucks because of our undefined slope. Because remember, Hoy tells you a 0 slope, so we're not using this one at all. And if you remember from bucks, that means we have a x equals equation. So we're just going to take the x value from those coordinates, which is -2. So it's just x equals -2. So you can either do it from the x values at the beginning, or you can actually find the slope and use the slope to tell you, all right, it's a bucks problem. So either way. All right, so now for 9 and 10, these are just word problems, and we're just looking for the equation that represents the scenario. So remember, our slope is going to be a reoccurring value. It's something that's going to indicate a term or a rate. So like each day, per hour, a day. So anything like that that indicates it's a repeated value. So a recording studio charges musicians an initial fee of $350 to record an album plus $75 per hour to use the studio. So automatically right here, we have $75 per hour. So that key word here is going to be per. So that tells you that 75 is going to be your slope. Now the initial fee of 350, anytime you have an initial value, that's your indicator that it's going to be your B value. That's where you start. So I'm just going to take that information and just plug it in. So y equals 75x plus the initial fee of 350. So that's your equation. All right, so now for this one, so Tara has $500 in her savings and she withdraws $35 a week. So our keyword here, there's actually two keywords in this phrase. The fact that she's withdrawing money, $35 a week. So that tells you $35 here, that's your slope. However, because she's withdrawing, she's actually losing money. She's taking money out of the account. So the amount is actually decreasing, which tells you it's going to be a negative slope. And then here she starts with $500. So our equation here is y equals negative 35x plus 500. So really use the context of those word problems to help you determine if it's positive or negative. All right. So the next page. So now we're going to be looking at the table values. We want to do the same exact thing. So one thing to note that I was very explicit in putting on here, you can actually do this same exact thing that we did for scatter plots, and you can use the regression model. So you can plug in y1 tilde mx1 plus b and plug in the tables, and it will tell you the equation. Or you can do it by hand, which of course I'm going to advocate for, but you also have Desmos as an option. So first off, if you notice here, we have 0, a number. So that's your indicator here that this is your B value. So we have the B value, now we need to find the slope. So in order to find the slope, I'm going to find the change between 2 points. Now, it doesn't matter what 2 points we use. It could be literally any points. So let's look at 4 and 5 here. So the change in y would be +1. Change in x over here would be +1. So if I do my slope, we're looking at the change in y over the change in x, which would be 1 over 1, which simplifies to 1. So I'm going to plug in to slope-intercept form. So I have y equals 1x plus my b value of 3. So I don't have to write the 1 right there, so I just have y equals x plus 3. Perfect. I don't know why that happened. Please leave. There we go. All right, so same idea over here. However, with number 2, I don't actually give you the y-intercept. I actually give you the x-intercept, which doesn't do us much good. So I'm still going to do the same old thing as before. So I need to find the slope. So 4 to 6 is +2. And 4 to 3 is -1. So that tells me my slope here is -1 over 2. Now I'm going to start with slope-intercept form. So I'm going to plug in an x value, plug in a y value from a coordinate. So I'm just going to choose 4, 4. It doesn't matter which one you choose. And then I'm going to plug in my slope, which is -1/2. So I have 4 equals -1/2 times 4 plus b. So now I want to solve for b. So I have 4 equals -2 plus b. And then to solve, I'm going to add 2 on both sides. So I'm going to have a b value of 6. So I'm going to take my b value and my slope and plug them in for slope-intercept form. So I have y equals -1/2 x plus 6. All right. Now look at number 3. So if you notice with number 3, there we go. All the x values are the exact same. So this is a similar indicator to a Hoy-Bucks problem. Whenever the x's or the y values are repeatedly the exact same, that tells you it's going to be a Hoy-Bucks problem. So because the x value is the exact same, that means it's going to be a Bucks problem. So my equation here is just going to be x equals 2. So you don't even have to do anything after that. All right, so for the fourth one over here, so if you notice, I just give you 3 random points. There's no common change amongst them. So it's the same idea as before. So let's say I go from 3 to 4. Well, that's +1. -4 to -7, that's -3. All right, so I know my slope over here. So change in y over change in x. So that's going to be -3 over 1, which is a change of -3. So same as before, now I got to plug in an xy value. So I'm going to use 3, -4. So I'm going to start with slope-intercept form. All right, so I'm going to plug in for y, m, and x. So for my y value, I'm going to plug in -4. For my m value, plug in -3. And my x value, plug in 3. And solve for b. So 3 times -3 gives you -9 plus b. Now I'm going to add over that -9 because you're doing the opposite. So -4 plus 9 gives you a b value of 5. So I'm going to plug in my slope and my b value. So I have y equals -3x plus 5. All right, so even if I give you a table as opposed to state coordinates, it's still the exact same idea. All right, so this is the part that might be a little bit new, but hopefully a little bit backwards. So before in unit 3, we've actually graphed linear equations based on an equation, but now for this, I'm going to give you the equation. Now I want you to provide me with the equation. So we're going to go a little bit backwards. So starting here at the very first one. So we're looking for 2 very distinct things, the slope and the y-intercept. So if you look here, the y-intercept, we have 0, 5. So that 5 is your b value. So now I just need to find the slope. So whenever you're finding slope, you can find slope between any 2 points anywhere on the line. It does not matter where on the line you start. If you want to do the slope way down here and look for 2 points, you can, or way up here, it doesn't matter. My advice is to use your y-intercept as one of your points. So if you look, we're going just up 1 and over 1. So +1 and +1. So that means your slope, which is going to be your rise over your run, which is 1 over 1, which simplifies to 1. And then we have a b value of 5. So our equation here is 1x plus 5. But as mentioned before, we don't have to write that 1. So our equation here is just y equals x plus 5. All right, so same idea with number 2. So I'm going to look for my y-intercept, so my b value, which is down here. So that is 0, -2. So I know that -2, that's my b value. So now I want to look for another point that I can use so I can find my slope. So if you look, you want to look for a very clear, concise point. So if I draw a little plus sign that kind of accentuates the grid, the line passes right through that intersection point. So what I mean is, for example, here, well, the equation doesn't pass directly through that intersection, so we can't use that. Doesn't pass there either. Doesn't pass there either. Nope. Nope. So we're really looking for just wherever it crosses. But if you look right here, our equation passes right through that point. So we can use that point as another point to find the slope. So now I want to find the rise over run. So I go down and right. So that means I went down 1, 2, 3, 4. So I went down 4, which means it's a -4. Then I went 1, 2, 3. So 3 to the right, which means I went +3. So my slope is going to be -4 over 3. So remember, it's going to be negative because we're going down. All right, and then your b value, which is -2. So I'm going to combine that. So I have y equals -4/3 x minus 2. So that's your equation. All right, and now for these last two. So as you can see, we have a horizontal and vertical line, which indicates Hoy-bucks. So for this very first one here, so I'm going to write out Hoy-bucks. So if you remember, H means horizontal and V means vertical. Well, here we have a horizontal line, so that was going to be Hoy. But if you look for number 4, that is a vertical line. So we're going to be using bucks for number 4. So over here, if I look at my acronym here, Hoy is a y equals. So I'm going to look at the y-intercept here. So that is 0, -2. So I'm looking at the y value, which is -2. So because the y value is -2, that tells you it's going to be y equals -2. So we're just taking whatever that y value is. So that's my equation. So same idea over here with bucks on number 4. So this coordinate here, if I can count, would be 8, 0. So now we're looking at the x value of our coordinate, which means we're going to have x equals 8. So that would be our equation here.